Now let's look at Lewis dot structures. Lewis dot structures are a really easy and convenient way for us to represent atoms, particularly when they're going through a reaction. All it shows us is the valence shell, the outer shell of electrons. So let's see what we get. Basically, Lewis dot structures, which we'll call LDS just for short, we'll still say Lewis dot structures, but we'll write it as, they're used to show bonding between atoms and the valence shell. Now remember, chemistry is essentially the interaction of electrons and from one atom and the protons of another. So here are some examples. Lithium has 3 electrons in the outer shell. That's not right. It's not, because lithium is group 1, which means lithium looks like this. Ah, I see what that was. That was an eye. My bad. That's a very poorly drawn eye. So, it's lithium with 1 electron in the outer shell. Okay, it's just drawn up top there. Chlorine has 7. So, 2, 1, 3, 4, 5, 6, 7. Carbon has 4 in the outer shell. 1, 2, 3, 4. Carbon has 6 electrons overall. Potassium also has 1 in the outer shell. And so they're up on its own. So the way it's drawn is we show the elemental symbol and the valence electrons. So you draw 4 around, like we did with carbon. You can do either circles or crosses, depending on it. And then you fill up the next layer around. So the way we would actually should have drawn chlorine is looks like this. 1, 2, 3, 4, 5, 6, 7. It's just the easy way to do it, or go the other way. It doesn't matter. That's what I did here. I started 1, 2, 3, 4, and then went 1, 2, 3. All right. So the group number of an atom is basically how many electrons will be in the outer shell. Okay. So this is in group 7. That's in group 1. That's in group 1. That's in group 4. It's different, of course, with the transition metals. Generally, they're drawn with dots, but you can use other symbols when you need to show the combining of 2 atoms. So let's have a look at that. So let's have a look at first ionic bonding. Then we'll go into covalent bonding. So ionic bonding is the sharing of electrons. Now, here's our equation. We've got magnesium, which has 2 plus, chlorine, 1 minus, which means we need to have 2 chlorines for every magnesium to get our MgCl2. So we draw it like this, right? Here's magnesium. Here's its outer shell. It's just got the 2. 1, 2. And it's drawn in that particular configuration so we can see what's going to combine with these. So we've got magnesium with its 2 electrons. Here we've got 7, and here we've got another 7. And you'll notice that magnesium has these crosses, whereas chlorines have the dots. And we'll see why. So the first electron comes down and joins this chlorine. This chlorine now has a stable outer shell. It's got 8. It's so happy. This chlorine comes across. This one now has a stable outer shell. So does magnesium. Magnesium's next shell down is now stable. Okay, so everyone's happy. We've got an ionic compound now. It's MgCl2. And this is how we write it. We write Mg and we put the 2 plus charge outside. You'll notice that there are no electrons in here because its valence shell is now empty. Whereas the chlorines, you've got 2 of these, so it's 2 times Cl, that should have a minus there. 1, 2, 3, 4, 5, 6, 7 electrons plus the 1 from the magnesium. So that's now got a stable outer shell. It has a negative charge. This one has a positive charge, and you'll notice because we multiply this by 2, they balance each other out. So the ions are drawn with their new valence shells. They're drawn in square brackets with the valency labeled on the outside. 2 plus, minus. And this shows the opposing charges actually, which is really cool. So if this is positive, this is negative. This shows why they're attracted together. It shows why those bonds are so strong. So that's another useful aspect of this. We can see this is a positive atom, this is an ion, and this is a negative ion, and that's why they're so closely attracted. Now if you have a look at covalence, covalent bonding happens with shared electrons. Okay, so here we have the burning of carbon in oxygen, and we get to burn it really well, so we get carbon dioxide. Covalent bonds share electrons. So shared electrons count as the valence electron for each atom. Okay, we'll see what we mean. Here, carbon has 4. Oxygen has 6 and 6. Okay, they're going to share the electrons. So basically, this here is oxygen's out of shell now. Okay, it's got these two, these two, these two, and these two. Okay, it's sharing 2 of carbon's electrons. That is a solid outer shell there. It's made that by sharing. Carbon only had 4, so it's got 1, 2, 3, 4. But it's also using 2 from the atom next to it. 1 there, 1 there, 1 there. And 2 electrons from this atom, which means it's sharing it, and it's giving it a stable outer shell of 8. It's a bit skew in shape, but it's a stable outer shell of 8. And here we have it again. 2, 2, 2, 2, 2, 2. And it's grabbed these ones as well. And that's sharing those electrons. And that has made it stable. I hope that made a lot of sense. That's really simple. It's a procedural thing. Remember, it's not magic. Just sit there and practice these Dob structures for any atoms you want. And yeah, if you have any questions, ask them in the comments below. We'll get back to you as quick as we can. And thanks for watching. We'll see you next time.